In this video, we're going to be reviewing some basic skills to get you ready for college algebra. We're going to be looking at multiplying binomials and factoring and solving equations using factoring. Okay, so the first few problems here, my directions say to multiply and then simplify. And remember that when we multiply two binomials, we can use the acronym FOIL, first, outer, inner, last, to help us with this. So first means the first two terms in each set of parentheses. So x times x is x squared. All right, the O stands for the outer. So the outer two terms are x and 2, so 2x. I stands for the inner two terms. So 3 times x is 3x. And L stands for the last two terms in each set of parentheses. So 3 times 2 is 6. And then we can combine these middle two terms, x squared plus 5x plus 6. Now you probably can do that in your head without having to write down the second step, and that's fine. Problem 2, notice that we have a subtraction sign in here, so you have to be careful with that. First two terms multiplied together give me x squared. The outer two, 1 times x. I can write as 1x, or you can just write it as x if you want to. The inner two terms would be minus 6x, and the last two terms multiply to give me negative 6. Combining those middle two terms, I have x squared minus 5x minus 6. Okay, problem 3 and problem 4 are here for us because later on we're going to do some really long math problems where these type of things are going to show up, and it's just a little part of a great big math problem, but this is where students usually make the mistake. This x plus 4 quantity squared means x plus 4 times x plus 4, and it helps to write that out. So take the time to write that out, and you can see that you're going to have two binomials multiplied together, so use the FOIL method just like we did on the first two problems. First, outer, inner, last. Okay, so once you combine those middle two terms, your final answer is x squared plus 8x plus 16. All right, problem 4, I would like for you to try to do on your own, so pause the video, do that, and come back and check your answer. And there's your answer for problem 4. Okay, the next set of problems, my directions tell me to factor, and remember that I can use FOIL to check my answer. First of all, what I want you to notice with these problems is these are what I call simple trinomials. There is not a coefficient here in front of this x squared term. If I know that this is a simple trinomial, then I can factor this into two simple binomials. If it can be factored, it's going to factor to look like this. Now what I want to do is find two numbers that multiply to give me 14. Okay, so factor pairs of 14 are 1 and 14, 2 and 7. So these are numbers that multiply to give me 14, but I also want those numbers to add to give me positive 9. So that means I'm going to be using the 2 and the 7. So x plus 2 times x plus 7 is my answer. And I can always check this by foiling. And I can see that that checks out. Okay, problem 6. Again, this is a simple trinomial because there's not a coefficient in front of this x squared term. There's not 2x squared or 3x squared. It's just x squared. So it's a simple trinomial. So I know that this can be factored into something that looks like this. So here I'm looking for factor pairs of 15, 1 and 15, 3 and 5. Now I want the numbers to multiply to give me 15 and add to give me negative 8. So if I need the two numbers to add to be negative, that means that both of these numbers over here have to be negative, right? When I multiply these two numbers together, I can get 15. And when I add them together, I want them to get negative 8. So I'm going to be using negative 3 and negative 5. So x minus 3, x minus 5 is my answer. Okay, problem 7, I have x squared minus x minus 12. If you need to, you can put a 1 here to help you with this. Again, I have just a simple trinomial. If it can be factored, it's going to be factored into 2 simple binomials. So here I'm going to look for factor pairs of 12. Now I really don't have a 12 here. I actually have negative 12. So I want 2 numbers to multiply to give me negative 12. That means one of the numbers has to be positive and one of the numbers has to be negative. And if I want these numbers to add to give me negative 1, then that means my bigger number over here has to be the negative. So what 2 numbers multiply to give me negative 12 and add to give me negative 1? It's going to be 3 and negative 4. So x plus 3, x minus 4. And one thing I want to point out here is that if you wanted to write this as x minus 4 times x plus 3, that's perfectly fine. My math lab does not care which order you put that in. So let me give you a minute to pause here and try and do problem 8 on your own. And there is your answer, x plus 7 times x minus 5. Okay, now with these next set of problems, we have trinomials that are not simple trinomials. Notice on problem 9 here, there's a 6 in front of this x squared. So it's not a simple trinomial. So what I need to do here is start by multiplying the leading coefficient by the constant. So my leading coefficient is 6, my constant is 6. I'm going to multiply that together and get 36. Now I'm going to list out factor pairs of 36. Now I want numbers that multiply to give me 36 and add to give me 13. Well, what I'm going to be using is 4 and 9. So I take that 13x and I rewrite it as 4x plus 9x. And I want you to be sure that you understand that 13x gets split up into 4x plus 9x. Now I'm going to factor by grouping. Group these first 2 terms together. And I'm going to factor out a 2x. That leaves me with 3x plus 2. Then in the second half of the problem, I'm going to be factoring out a 3. That's going to leave me with 3x plus 2. And then I can factor out 3x plus 2. And I'm left with 2x plus 3. And if you want to, you can go back and FOIL this to double check to be sure that you have the right answer. Okay, problem 10. Again, I have a coefficient in front of this x squared, so I am going to multiply my leading coefficient times my constant. 8 times 3 is 24. And I'm going to list out factor pairs of 24. Now I want numbers that multiply to give me 24 and add to give me negative 14. Well, again, remember that when I multiply 2 positives, I get a positive answer. When I multiply 2 negatives, I get a positive answer. What it's going to add to give me negative 14 would be negative 2 and negative 12. So I'm going to take that negative 14x and rewrite it as negative 2x minus 12x. Hopefully you can see where that just gets split up into 2 different terms. Now I'm going to group these first 2 terms together, factor out a common factor of 2x. Group the second 2 terms together and factor out a 3. Now I have 4x minus 1 in both sets of parentheses, so that gets factored out. And there's my final answer. Okay, with problem 11, again, I do not have a simple trinomial. I've got a leading coefficient here of 8 and a constant of 21. So I'm going to work this problem very similar to the way that I did problem 9 and 10, but I'm going to do something just a little bit different here because I have such big numbers. I want to show you how to use your calculator to help you with this. So the first thing I want to do is multiply 8 times 21, and I'm going to get 168. If I tried to make a table of factor pairs for 168, that's going to take me quite a while to do. So what I'm going to do is to use my calculator. Okay, what I want to do is go to this y equals key up here in the upper left-hand corner. And I'm going to type in 168 divided by x. Now I want to go to this table, which is the second function key. So I need to hit second table. And what you should notice here is that on your screen, you're going to have 0 and error. And that's okay. You should have that because what the calculator is doing is it's taking 168 and trying to divide it by 0. Well, we can't divide by 0. Then it's going to do 168 divided by 1, divided by 2, divided by 3, and keep going like that until we list all of our factor pairs. Well, I want numbers that multiply to give me 168, but I also want them to add to give me negative 34. So I know that my two numbers both have to be negative. So if I start looking at negative numbers, I can see like right here, I've got a negative 2 and a negative 84. They multiply to give me 168, but they add to give me negative 86. That's not what I want. Right, so here, these two numbers will add to give me negative 46. That's still too big. So keep going. And here you can see I have negative 6 and negative 28. Those are the two numbers that I want. They're going to add to give me negative 34. Okay, so I'm going to rewrite this middle term as negative 6x minus 28x. And then I'm going to group these first two terms together, factor out a greatest common factor of 2x. Group the second two terms together. I'm going to factor out a negative 7. You can see I have 4x minus 3 in both sets of parentheses, so that gets factored out. And I'm left with 2x minus 7. And if you want to, you can go back and FOIL that just to double check to be sure that you have the right answer. All right, problem 12, you can see I've got a leading coefficient here of 6. So I'm going to multiply my leading coefficient of 6 times my constant of negative 25, and I get negative 150. Okay, so again, I'm going to use my calculator. I'm going to go to the y equals, and this time I'm going to have negative 150 divided by x. And then I want to go to this table, so I'm going to hit second, and then table, and that's going to give me my factor pairs. So I want numbers that multiply to give me negative 150, so I've got to have one negative and one positive, and I want them to add to give me positive 5. So I know that my bigger number is positive and my smaller number is the negative. So I'm going to scroll through here, and I can see that I've got negative 10 and positive 15. Those two numbers are going to add to give me positive 5. Okay, from here I want you to finish the problem out on your own and then come back and check your answers. And there is your answer. Okay, problem 13, you can see that I have x's and y's in this expression, but we're still going to do this basically the same way. We're going to multiply this number up front, 9 times this number at the end, 16. 9 times 16 will give me 144, and if you need to use your calculator to help you with this, that's fine. I want numbers that multiply to give me 144 and add to give me negative 24. That's going to be negative 12 and negative 12. So I'm going to rewrite my expression with minus 12xy, minus 12xy in the middle. And then I'm going to group these first two terms together and factor out a common factor of 3x. And then I'm going to group these second two terms together and factor out the greatest common factor of minus 4y. And then from there, I can see that I've got 3x minus 4y in both sets of parentheses, so that gets factored out. So I have 3x minus 4y times 3x minus 4y. Okay, problem 14, we're back to having just a simple trinomial because I don't have a number up front of that x squared term. So if this can be factored, it's going to be factored into two simple binomials like this. And I want numbers that multiply to give me 10, so it's either going to be 1 and 10 or 2 and 5. And remember that numbers that multiply to give me positive 10, they either both have to be positive or they're both negative. And if I want these numbers to add to give me negative 3, then I would need to have them both to be negative if it's going to work. But if you can see here, negative 2 times negative 5 is not going to add to give me a negative 3. They multiply to give me positive 10, but they don't add to give me negative 3. So this actually can't be factored, and we call that prime. Okay, in these next set of problems, we have equations that we're asked to solve. Now, this type of problem is different than just a regular linear equation where you're trying to isolate the variable. When you have a quadratic like this, where you have x squared, what you want to do is to be sure that your equation is set equal to 0. So everything is on the left-hand side. Now what I want to do is to factor this. This is a simple trinomial. It's going to factor into x plus 2 times x plus 5. So here I have two things that are being multiplied and I get 0 for the answer. The only way that I can multiply two things together and get 0 for an answer is if one of these is 0. So either the x plus 2 has to be 0 or the x plus 5 has to be 0. So x could be negative 2 or x can be negative 5. If you were to put either one of those numbers back in place of this x up here, you would get 0 for your answer. Okay, with problem 16, notice that this is not set equal to 0. So I have to get that 10 over on the left-hand side, so it ends up being minus 10. So from here, I can factor. So I get x minus 5 times x plus 2. Then I'm going to set each factor equal to 0 and solve. So I end up with 5 and negative 2 for my answers. Okay, with problem 17, notice that I have a quadratic that's not just a simple trinomial. So I need to multiply this leading coefficient of 2 times my constant, so I have negative 60. So I'm looking for factor pairs of negative 60. Well, I'm going to go ahead and write out just factor pairs of positive 60. And if you want to use your calculator, you can do that as well. Now I want to be sure that I multiply two numbers that give me negative 60. That means one of the numbers is positive and one of them is negative. And if I want them to add to be a positive 7, that means my bigger number has to be the positive and my smaller number has to be the negative. So what I'm going to have is 2x squared minus 5x plus 12x minus 30. And I'm going to group these first two terms together and factor out a common factor of x. Grouping the second two terms together, I'm going to factor out a 6. And then factor this into 2x minus 5 times x plus 6. Then I'm going to set each of these factors equal to 0 and solve. And there are my answers. Okay, I would like for you to pause the video and try and do problem 18 on your own. Okay, and there are your answers.